In today's video, we'll be talking about the wave equation. After watching this video, you should be able to define the frequency and period of a wave, understand how energy transport and amplitude are related in a wave, and be able to use the wave equation to calculate the speed of waves. All right, let's get right to it. So two definitions for you guys, and I used this in the previous video, so I apologize that I hadn't explained this a little bit more thoroughly, but frequency, which is typically represented by an F, and sometimes it'll look a little bit like it's a slanted F, of a wave, refers to how often the particles of the medium vibrate when a wave passes through the medium. Okay, so typically the units are cycles per second. Okay, so let's say if you have a wave and it passes through 2 times in 1 second, it would have a frequency of 2 hertz because you had 2 cycles in 1 second. Okay, so you may have heard of frequencies that would be like 400 hertz. Well, that would be 400 cycles happen per second, so it's pretty dang fast. Okay. The period of a wave is the time for a particle in a medium to make one complete vibrational cycle. And the units for period is seconds per cycle. And so these two are definitely related to one another. And so there's 2 formulas down here on the bottom that are pretty important. The first one is the formula for period, and the period is 1 over frequency. And remember, period is typically represented by a T. And the frequency, which again is represented by this kind of weird looking F, equals 1 over period. So you can, if you know period, you can certainly find frequency. If you know the frequency, you certainly can find the period, and vice versa. So here we have a wave, okay, and we get 20 waves in 1 second. Okay, so 20 waves will pass by in 1 second. So that's a frequency of 20 hertz. Okay, that's what that means. So how much of a one wave is 1/20th of a second? Okay, so basically, 1 wave will pass by in a 20th of a second. It's really fast. So your period is 0.05 seconds. So frequency of 20 hertz, and one complete wavelength passes by in 1/20th of a second. And that's basically the difference between period and frequency. The period is how long does it take for one wavelength to go by, whereas frequency, it's how many waves will pass by in 1 second. So you're kind of changing the parameters of what you're measuring. Let's take a look at an example problem, and this might help it make a little bit more sense. It says, what is the period of a sound wave produced by a 440 hertz tuning fork? Okay, so I'm looking for the period, which is T, and I know the frequency, which is 440 hertz. So I'm thinking the formula I might want to use is T equals 1 over F to find out my period. And so I basically just plug numbers in, and I have 1 over 440 hertz. What does that equal? And the answer is 0.002 seconds. Okay, so this means, what does this number mean? This means that it takes 0.002 seconds for one wave to pass by. Okay, just one wavelength will go by in 0.002 seconds. So that's pretty dang fast. And in 1 second, 440 waves will pass by. All right. So let's do another example problem. A period of 2 seconds, so period is T, a period of 2 seconds corresponds to a frequency of blank hertz. Okay, so I'm going to just use the equation that I had in the previous slide. F equals 1 over T. That's supposed to be a 1. Sorry, it doesn't look like a 1. 1 over T. Let's see here. We have a period of 2 seconds, so we have 1 over 2, and that equals 0.5 hertz. So the next thing we want to talk about, and I again briefly mentioned this in the previous video, where the energy of wave transports is related to amplitude. And just a reminder, and again, this is showing up a lot because it's important, waves do only transport energy, not the medium through which they travel. So again, in the previous video I talked about like a rope, and if you shake a rope up and down, you don't like get a big pile of rope down here, right? After you keep shaking the rope up and down, it's not like more rope starts appearing at the end. All that's being transported is the energy. And the amount of energy transported is directly related to the amplitude. So here on the left, I have a low energy wave because the amplitude, the height from this equilibrium line to the crest or trough, is not very high compared to this wave where the energy is very high because the amplitude is very tall. Okay, so amplitude is just, again, a look at how much energy the wave is transporting. So now we're getting into more of the wave equation. The speed of a wave is how far a given point in a wave travels over a period of time. And that's really no different than what you guys were learning in first semester physics, where speed equals distance divided by time. So keep that in mind because we're going to talk about the different types of wave equations that you can have. Reflection of waves do happen, and it's very common. And so think of a sound wave echoing in an empty room. And there'll be problems where you have to kind of think about, well, if a wave traveled 170 meters to get to a cliff or whatever, and then had to bounce back 170 meters, what is the total distance the wave had to travel? And that could be kind of a confusing way I could ask for distance. So keep that in mind, that waves do reflect, and we'll talk more about that in later lessons. Now you may be asking yourself, all right, we can calculate wave speed, that's great, but what determines the speed at which a wave travels? And frequently students will say, well, the frequency does, or the wavelength does, and neither of those actually determines the speed of a wave. The only thing that determines the speed of the wave is the medium in which it travels through. So sound waves traveling through air travel at a different speed than, say, if they travel through water, or if they travel through like steel. So the medium in which the wave travels through is actually going to be the deciding factor in terms of what the speed of the wave is. So keep that in mind. That's another important point, that the speed of a wave is determined by the medium in which it travels through, not the frequency or the wavelength of the wave. That actually doesn't matter in the end. So here it is, the wave equation in all its glory. The wave equation, which is the speed, and represented by a v for velocity, can be determined by the following equation. V equals frequency times the wavelength, okay, frequency times the wavelength, or if you want, you can use speed equals wavelength divided by the period. Okay, either one works just fine. So if you're more comfortable dealing with frequencies, then convert it to frequencies. If you're more comfortable dealing with periods, then change it to periods. Because in the previous slides, a few slides back, I told you how you could basically do that, where you just take the number and take 1 divided by f or 1 divided by t, and that gets you frequency or period. So here's a speed problem. And something I could ask you guys. 2 boats are anchored 4 meters apart. And so if you take a look at this picture, here's this water wave right here going down. Okay. 2 boats are anchored 4 meters apart. Okay. They bob up and down, returning to the same up position every 3 seconds. Okay. When one is up, the other is down. There are never any wave crests between the boats. Calculate the speed of the wave. Okay. The first thing that we should notice is that from this crest to this crest is 8 meters. And so what is that? What is that distance actually telling us? That right there is the wavelength, which is represented by lambda, and that's 8 meters. Okay? So the wavelength is 8 meters. And this would be half a wavelength. 4 meters would be half a wavelength. Okay? It says they bob up and down, returning to the same up position every 3 seconds. So what it's really saying is that it will take 3 seconds, if this boat's up right now, it will take 3 seconds for it to be up again. So that is referring to the period, right? It takes 3 seconds for a wave to, for the wave to pass through, okay, for one wavelength to go by. And so we just learned in the previous slide that we can calculate velocity based upon this handy-dandy formula, wavelength divided by t. And if we plug that in, 8 divided by 3 equals 2.67 meters per second. Now, if you don't like using period, you absolutely could take the formula F equals 1 over T and divide 1 divided by 3 and get the same answer. And you could use, instead of V equals wavelength over period, you could use V equals wavelength times frequency, and you'd get the same answer, 2.67 meters per second. All right, so that takes care of this video. I will see you guys next time.